think about the question that I asked you. So think about the question that you asked. The question that you asked each other was, are you full-time or not? So standard deviation would kind of mean that you're kind of not full-time, or you kind of are full-time. And that's not true with categorical data. You either are something or you're not. Does that make sense? So you are either a full-time student or you're not. There's no standard deviation of full-timeness. Yeah. Yes. Right? That's what's nice about this is the proportions only apply to categorical data because it has nothing to do with numerical data. In fact, we can use that to determine the different types of questions. And from this list over here, right, I'm going to give you guys one specific question for us to be able to tell whether it's about averages or about proportions. And we're going to actually use the fact that this is categorical data and the other one is numerical. Future us. All right. There is a formula for this. Yes, that is a giant square root. Didn't hear anybody sigh.
I'm just really just questioning.
I haven't answered that. Let me finish this point before I forget it. This, P. Do we have this? Will this be given to you?
Yes.
Yes, this is the proportion of successes. 1 minus P. So if you think about this, if this was my proportion of successes, this was the proportion of people who were full-time. What's the proportion of people who were not full-time? 0.8, right? If 0.2 are full-time, that means 0.8 have to be not full-time. So that's really what this guy right here is. There's another version of this formula that has a P and a Q, but I don't care about that because then you're asked to memorize, oh, well, P is the proportion of successes, so Q is the proportion of failures. Yeah, forget about all that stuff. Look, this is the proportion of successes. This is 1 minus that value. Okay, so these two guys right here, when we're all said and done, they'll add up to 1. Divided by n. Will we be given this value here? Yes. For our example, it's 5. I will give you all formulas on the exam. The reason why we do this is not really for this, but it's for after the exam. Because we can use the fact that, remember how last class that if your sample size was big enough that it always turned into a normal curve? So then I can use the fact that it's predictable to tell what could happen. Does that make sense? So if I take enough samples, even with this, if I do enough samples, and we can go to StatKey and we can reproduce this a whole bunch of times to where this guy right here is also going to be predictable. So if I know that my sample is predictable, then I can gather information about my population based upon my sample. That's where we're going with this. So this is a lot of theoretical stuff is what we're doing now, but after this is very, very, very applied. A wonderful example of this is, you know the average weight that people can take on flights?
With the luggage, you mean?
Yeah, with your luggage.
I think it's like 65 pounds.
But I think it depends on which one, but I think it's like
It depends on which airline.
right. So let's just say it's her 65 pounds.
Okay.
Where do you think they came up with that number at? Because what they've done is they've said, okay, so let me take a bunch of samples, a bunch of samples, and let me see how much weight people are normally bringing on and how much flight fluid or how much gas that we have, and then we can say that that's why it's different for each one, depending on how far you go and how much luggage people are going to bring on. You can do this. I mean, this is very, very applicable after this exam. For right now, we just got to get through this little lame theoretical stuff. Okay. I have a mean, I have a standard deviation. So then the only thing that I need that's left is the third part. If I can show that the sampling distribution of sample proportions is normal. If I can somehow show that when I make a graph of this data here, right? You take out the same, you take out the same thing, you take out the same. If I make a graph of these data points, if I can show that this is normally distributed, then we can do all the stuff that we did last class, we can do all the stuff that we did for the class before. We have our 4 steps. We can use stat key to come up, SALT. We can use SALT to do our math because we have an average, we have a standard deviation, and we know it's normally distributed. Right? So this is the big thing. Because I have an average, I have a standard deviation, I just need to show this. And the way that we show this, do you hear something?
Mm-hmm.
Oh, there's a bug. Can I kill it?
Yeah.
Like I can't, you guys said I can't kill ladybugs.
Is it like
Is it a ladybug? Whatever bug.
It's a giant thing.
So then it's not like out. Throw your sweater at us.
No, you can spray it.
There needs to be at least, well here, 10 or more.
Stop playing.
10 or more successes and failures. 10 or more successes and failures in our sample. Well, we'll just leave it as 10 or more successes and failures. So this is easy enough to check. In fact, for yours, is it possible for this guy right here to be normally distributed? It's not, because I had you guys only ask 5. So is it possible for me to get 10 successes? No. Is it possible for me to get 10 failures? No, because we didn't ask enough people. Right? So we'd have to make the sample sizes much larger for this to be normally distributed. But this is a simple thing to check. The way that we check this, successes, this is just, we take our sample size, we multiply it by p, multiply it by our proportion of successes, we check to make sure that is greater than or equal to 10, call it a day, for our successes.
Can you like just go back 5 seconds?
The way that we check our successes is we take our sample size, that's the n, we multiply it by p, that's our proportion of success, so n times p. Once we check n times p with Mr. Fancy Calculator that multiplies, make sure that value is greater than 10, then we are done with the successes. Now we just need to repeat that with the failures. So n times the proportion of failures, well for us that's 1 minus p, make sure that's greater than 10. It's not nearly as bad. It just seems like a lot. Okay, question number 1. I was watching SpongeBob when I thought of this one. So with this, before I even begin this, we did question number 2 from before, right? This was the one that I did last class.
What was your question again?
How can you tell that question number 1 is categorical? How can you tell that question number 1 is proportions? And how can you tell question 2 is numerical? It's about averages.
Well, isn't it the context of the...
Yeah, it is the context, but we need a simple way. We need a really, really simple way. Because I can't just go, well, what's the variable here? And the variable here is who you voted for. Wait, well, okay, so who you voted for is categorical. Right, I want something easy, something really, really simple. And I think I have a very simple question. Yeah, what's yours?
Isn't in the 100 of these cigarettes?
Right, well, that's how I know to do it with the sampling distribution. Right, because that was the one from before, right? If there was a sample size, then it was, right, then we could do that with X bar. Well, now if there's a sample size, because is there a sample size for this one? So now there's a sample size for this one, so we can't quite rely on sample size. We will, but not quite yet. Yeah.
Is it that it says random?
No, not because it says random. Both of them say random, don't they?
Majority.
Yes. This one specifically states a standard deviation. So this brings back to what she was saying. This question right here, does this question have anything to do with a standard deviation?
No.
No, it's categorical data. Categorical data does not have a standard deviation. We will calculate one, but not for what we're given. Right? Inside the question someplace, if there is a standard deviation, so here, is there a standard deviation? If you say yes to this, what type of question is it? It is numerical, which means it is X bar, which is all the stuff that we did last class. If you say no to this, it's categorical, so then it is P hat. All right, so let's go through the steps. All right, question number one. Again, this is posted in Blackboard, right? It's underneath the sampling distribution class examples. So, again, what I'm hoping that students do is that they read the question and they're like, okay, is there a standard deviation in this? No. So since there's not a standard deviation, this must be a p hat question. So you go through the whole Rolodex of steps. What are the steps for a p hat question? Well, label. You have to label a p hat. So let p hat be the proportion of how many and what are they doing? So what is this question about?
Registered voters.
And who did what? Well, how many?
500.
So let p hat be the proportion of 500 registered voters who did what?
Voted for Patrick.
Voted for Mr. Starfish. So this is very similar to what we did last class, right? There's my notation. Last class it was an X bar. This one is a proportion. Last class it was an average. There is my sample size, and this is what they're actually doing. This is the part that I'm actually interested in. Conditions. What do you think the first condition might possibly be? You have to flip back. This is literally the same. It's exactly the same conditions as what last class was. Random sample or the sample represents the population, right? This is going to address bias. So what do we have here? Is this a random sample? Does the sample represent the population?
It's a random sample.
Okay, so told a random sample of 500 voters. Okay. So letter 2. Again, flip back if you have to. It's identical. The other one. Yes. So 2 is the 10%. So is 500 less than 10% of all registered voters? Is that a safe assumption? Yeah, because that means that there's like 5,000 voters. I'm pretty sure that there's more than that. So 500 500 is less than 10% of all voters.
So we have to just assume that.
Yeah. 3. How do we check if it's normally distributed? It'd be awesome if there was something written on the board for us to check or proportion questions someplace. These two. So, successes. Before we begin this process, let's make sure we have our labels correct. What is N? Sample size, and what's that for this one? 500. Alright, we like that one. P. First of all, what does P mean? It is the population proportion. So since it's a population proportion, is it describing a small group or is it describing everybody? It's describing everyone. So I see two values up here. I see a 48%. Oh, and then we'll get into this. Majority. What is that 48%? Is that describing all or is that describing my small group? I'm like, you guys kind of, some of you guys said all and then small starts with, has the same ending there too, so I was a little confused. All. So therefore, this 48%, this is the population proportion. This is the P. So this is 0.48. So now what's P hat here? It is the sample proportion. So this is going to be the sample proportion, this P hat, if you want to make a note of this will always be in the question somewhere. Just like for last class, it was always in the question. Last class it was more than 84. So that's in the question. So this is my sample. So this is my X bar, right? This is my statistic. When somebody says majority, what does that mean? More than half. So P here is going to represent that half. So this is 0.50 because we want to see how likely it is for us to get a sample that has more than half. Make sense? Because 0.51 is still more than half. Right? For a majority, you just need something larger than a half, larger than 0.5. All right, successes. N times P. Do we have an N? Yes. Do we have a P? Yes. So this is 500 times 0.48. Let's go with a fancy calculator that will multiply. 240. And the failures? N times 1 minus P. Do I have an N? Okay, so for you non-mathematical people, this is like $1 minus 48 cents. How much change do you get back? 52 cents. 52 cents. And you guys can multiply if you so choose. 500 times 0.52. It is 260. It shouldn't be any surprise that this is 260 because this is my proportion of successes. So this is the number of people who I would expect to vote for this particular, whatever, for this sample. This is going to be the failures. So if 240 were successful, out of 500, how many are left? 260. These two numbers right here will always add up to whatever my sample is.
Exam, since we can do it that way, like just in our head, do you want us to still write it out?
No. But if I don't write it out, then you're going to get home, you're going to be like, I have no idea. I'm just making up numbers. All right. So I have a label. I have conditions. What's my third step? math. I am still finding a probability. But now the notation, what goes in here, is the same thing that we labeled. P hat. Now we can use the question to figure out the rest of this. Since it wants a majority, I know that this value here must be 0.5. I don't know what this is, but I want something here. Greater than or less than?
Greater than.
Greater than. So, we know it's normal. We can make a sketch of a bell curve here. What is the value that goes down the middle of this? Well, what is mu of p hat equal to? It'd be really awesome if we wrote it down someplace. Mu of p hat is equal to p.
Okay, yeah. You said that, you did say that.
P is the population proportion. It would be really awesome if we wrote p equals a number someplace over here. Sigma of p hat. Really awesome if we had a formula for it someplace. Do we have a value for p? Does it say p equals someplace? And do we have a value for n? All right, get out those fancy calculators of yours. You have to make sure that you do this correctly. You guys remember how to do your wonderful order of operations? Everybody remember my Aunt Sally? It's funny because I actually have an Aunt Sally. She's hilarious. So, you're supposed to do whatever is inside the parentheses first. So this is 1 minus 0.48. Then you take 0.48 times that. Then you divide that by 500. Then you take the square root of it. Since you're going to use that calculator, you just have the whole thing in. It's exactly how you see it. I need to make sure that you guys understand how to get the value for this. Because if you don't, then you can't make a sketch. So take a second and actually do this. You can just plug it in just like that, yes. You can just plug it in just like that. I can plug it in just like that. What is that?
What?
It's exactly like yours. What was that?
Wow, I got that right on the iPhone. I mean,
How'd you do it? Which button did you press for the square root?
I pressed the 2 with the X,
Oh, okay.
and that did it. I can ace this class. You got something close to it.
I was concerned about
I think that's right. Yeah, mine had like a bunch of zeros, but I still got close enough.
As long as you do it just like that every single time, that's what I just want to make sure is. I want to make sure that however you're doing it, it is repeatable. If you did not get that, then we need to figure out how you can get that. You didn't get it?
I don't remember how to use that touch.
Oh, nice. So that's like last year, right?
No.
Alright.
So I want you to type in just the top part right there.
I mean, I can get it, but it has.
Yeah.
And it's no sense in learning how if you're just gonna get something else.
Yeah.
Okay. Everybody get it? Sadly, what is the value that goes down the middle of this? 0.48 here. What is this number that goes here? I think that there's a 2 there. 5023. Okay. I'm only interested in 0.50. So I can essentially stop here because, oh wait, I can use blue since I didn't bring the red.
Yes.
Here is 0.50. Where am I shading? Above this or below it? Above. So what should my answer be? Should it be big? Small? Should it be close to 0.9 or significantly smaller than that? Should it be less than a half? Greater than a half?
Less greater.
Should be less than a half, right? Because I have shaded less than a half. So now the rest of this is exactly like what we have always been doing. So salt, send gauge. Normal distribution, do I have a mean?
Would that be the
0.48. Do I have a standard deviation?
0.0223?
223. Do I want my right tail, left tail, both tails?
Right.
Right tail, and then what is the number that goes here?
0.50.
0.50. And I get 0.1849. Oh, look at that. Isn't that amazing? Can you guys read that?
Yeah.
I mean, isn't that awesome? Remember that other classroom? That thing sucked.
Yeah.
Zero,
You could see
zero?
this one like that here.
I know, that's amazing.
It's 10. It's
0223
or 0023?
0223.
0.0223. 0.0223.
Oh, never mind.
All right. How do we finish it? Statement. All right, so let's do what we found. The easiest way to do what we found is always to revert back to the question. So, what did the question ask us to find?
What is the approximate probability that of the majority will vote?
Okay, so we can just stop there because the rest of that stuff is just like extra information. So what is the approximate probability? Well, we have that, right? That's 0.1849. So I'm going to change this. The probability that 500 voters will vote for, well, hold on, I got to word this right because I didn't include the word majority there. So let's do this. Is a 0.1849 probability that the majority of 500 voters will vote, or not vote, is all that asks us to find. That literally answers the question. What is the approximate probability that of those 500 voters, the majority will vote for Patrick Starfish? So again, if we wanted to, you can seriously just reword this beginning part above in front of the comma, and that's all I've actually done here. Now, what are we assuming?
So that 4.8 voted for him.
Right, and that's it, right? Do we say anything about it being normally distributed?
No.
Does it say anything in this entire question about it being normally distributed?
No.
Does it have anything about an average here?
No.
Does it have anything about a standard deviation here?
No.
What is the only thing that we are assuming?
That point.
That's it. That's the only thing that we are assuming. Assuming that 48% of all voters actually voted for Patrick Starfish. Okay, should we do another?
Yes.
So on the exam, question like this, when are we?
Yeah, that's why I keep on asking on the exam. Underneath the math part, I will say math setup and sketch, and then I'll say your answer is one of these. So as long as you make your sketch semi-right, then right, there's only one answer here that is even remotely correct. Right, it can't be this one. It can't be this one because this is over half, and this one is the only one that is under half, and that's what I've shaded here. So I try to pick values here that it's just impossible to do. Well, if you make your sketch, that's why we keep on doing the sketches over and over and over again. It's for you guys to know that, look, this is what we're doing with this.
Is the exam as long as the one for the first one?
No. It can't be. You'll never finish. There's only 3 open-ended questions. And less.
Do they hold like higher point value then?
Yes. Because, well, this guy right here, oh wait, we can actually go through this. For this, how many points is this part right here worth? Just the label. 3. Do you have to have the p hat? Do you have to have the 100 or the 500?
Yes.
And then you have to have who they voted for. Yeah. What about the conditions? Definitely have to have this. Have to say something about random sample, right? And address identify the sample. So this is 1. This guy.
1.
1. This guy.
2. 1. 3.
1, 2. There's actually 3 here, and I left 1 out. Here. Do you have to have this?
Yes.
Yes. You have to have the greater than, and then this guy right here. Then the sketch. So maybe 4 points. Something like that. What about the statement?
The answer.
If I'm not grading the answer here, why am I not grading the answer here? Because I graded it over there. So, majority of 500 voters who will vote for Patrick Starfish, and then what you are assuming. So this part right here is only 3 points.
How many of these?
2. There's 1 with an X bar and then 1 with a P hat.
And the other one's a random, is the regular sample?
The uniform distribution, which you've forgotten how to do.
Can you give us an example with the How do you know?
All right, the part that I missed about this. Right, the whole reason why we check these guys right here is to make sure it's normally distributed. Did I say that it was normally distributed here?
No.
No, so we actually have to state that the sampling distribution of sample proportions is normal.
In the conditions section?
Yes. You have to use this exact verbiage. Sampling distribution of sample proportions is normal. Is normally distributed is fine. What I get a lot of here is somebody will say, it's normal. And I will count that wrong. I will get somebody that will say, the sample is normal. That's not right either, right? The sample is not, right? You either were a full-time student or you weren't. You either voted for somebody or you didn't. It's not distributed. You have to use this exact language. Up here, what I will get a lot of is I will get somebody that'll go A, random sample, B, less than 10%, C, greater than 10. And I will count it all wrong. Every single time. Because you don't understand what this is. Right here, you're addressing the sample. So you say something about the sample in this one. This one right here requires the sample size and the population. So you need to address the sample size and the population. Then this, the math, then make sure that you use this language here. All right. I don't want to do, let's see what's on the other one. All right, real quick. There's one on here. There's another X bar question on here, but I don't want to do it, and I'll explain why here once we get a little bit further. This guy right here, we just did. This is a p-hat question. We did this, or I did this one last class. This was an X bar. Read question number 3, and tell me if it is a p-hat or an X bar question.
Do a countdown first. Like,
Number 3.
so that we can all say it together.
Oh, okay. Just think amongst yourselves for a second.
Thanks.
I will erase.
Oh.
Okay, X bar?
Thanks, Mom.
Is it an X bar? Why do you think it's an X bar?
Standard deviation?
Where does it say standard deviation in that
Number
question?
4, right?
Oh, no, number 3.
Great.
No, p-hat. It doesn't
Fabulous.
say standard deviation.
You are absolutely correct. Number 4 is an X bar question.
Thank you. Okay.
Number 3, p-hat. Why?
No standard deviation.
There's no standard deviation. 3 is definitely p-hat. 4 is an X bar question. Yes. Why?
Because it's the standard deviation.
Standard deviation is this. 5.
Can you raise it up?
Is there a standard deviation?
No.
So that one is p-hat. Here's the Bert-Ernie ones. Alright, fine. We'll do this one. So we'll do 4. Alright. So, first thing that you guys should do whenever you guys go through this is you need to read it and ask yourself, is there a standard deviation? This one does, so I automatically know that this is an X bar question. So you go through the old Rolodex. The label should be X bar with an average. Right? The conditions. First condition is still going to be random sample. Second condition is going to be less than 10%. The third condition We either have to be told that it's normal, or the sample size there has to be larger than 30. Remember that? We'll get to that. Then there's specific formulas for the math, and then we'll have to write our statement. So again, before I even start doing these questions, like okay, so this is an X bar question, so I can kind of see it in my head, like X bar, I need these specific things. So, label. As soon as I see a standard deviation, I'm thinking of that. Let X bar be the average of whatever. Now I have to go fill in the whatever, right? This one requires a sample size, and what am I talking about for this one? So this is going to be the average. Let me see here. How many did we do? Right, because I need a sample size in this. So how many? So the average number of fluid ounces in 50 bottles. Okay. That's probably the average fluid ounces in 50 bottles.
Of soda.
Sure. Did I put soda on this one? Originally it was beer, but then I found out a lot of my students are not old enough, so I had to change it. Oh, soda.
Right.
Also, it's weird for me to say soda. I'm not from the East Coast, so I don't say
Pop. Please don't tell me you say pop.
I did for many years, yeah.
Pop.
Until
The way you're judging it.
yeah, so again, like I have one high school friend who's the director of a newsroom, and he's like, "Pop, is this your dad?"
Exactly.
He's from Jersey.
Right, there you go.
So yeah, or then it's worse because then every soda for me is also Coke. Like it's all just
It's
Coke.
all Coke. No
So-
Sprite.
No, so it's like any sort of that isn't Coke. Anything that is caffeinated is Coke. So going to ShopRite for the first time, yeah, I got a case of Coke down here, and it's like Sprite. The person was like, "What? Case of Coke down there? You mean the Sprite?" Yes.
Sprite is Coke. It's Coke. Pop.
All right, conditions. First condition, always the same. Do we know if it's a random sample, or does our sample represent our population?
It's a random
No, it's random.
So we were told this. Okay, so told random sample of what? What is our sample here? You have to identify the sample.
50 bottles.
50 bottles. What are two?
50 bottles is less than 10%
Of?
the population of all bottles.
Can we do one, would it be a question where it would be greater than 2%?
It's always less than that. So if you remember it like this, it makes it a lot easier. So that's why I like the way that she said it, because the 50 bottles, right, that's my sample, is less than 10%. Take out the number, write the word all, and repeat whatever my sample is. That's what your population is, right? That's how we've always done a population. Take out the number, say the word all, and then describe it the same. So 50 bottles is less than 10% of all bottles. Does that make sense? All right. 3. This is not successes and failures. Successes and failures only apply
What's the
with the other one.
50 P X bar is less than 30%. Or less than that.
I'm really confused. So here, one of two things, right? So there's two things. We either have to check to where it says normally distributed in the question somewhere. Does this one say normally distributed?
No.
If it did, then we would say, since we are told it's normally distributed, the sampling distribution of X bar is normal.
Yeah.
Since it doesn't say that, does this mean that we're done?
No, it has to be more than 30.
More than 30. Is the sample size larger than 30?
Yes.
Yes. Since 50 is greater than 30, I'm going to repeat this exact line. I'm just going to say average instead of proportion.
So that's really the problem.
What did you
Because
write?
you have to.
Sampling distribution of sample averages is normally distributed.
What?
Alright,
Sampling distribution of sample averages is normally distributed.
You lost me.
Where?
It's just you writing.
With this?
Yeah.
The sampling distribution of sample averages is normally distributed. So this line?
Yes.
This line is exactly the same as this line. I just didn't put a normally distributed on that.
but you put a whole bunch of other shit on it, so that means this one does not require.
Right. That one over there requires successes and failures because it's a proportion question. This one we either have to be told it's normal or the sample size is better or larger than 30. Because it's X bar. Because it's X bar. Alright, what's the third step?
Math.
Alright. This notation must be an X bar. Now go into the question someplace. We can figure out our inequality, we can figure out what that other number is. In the question, it's going to tell us the notation. Or less. So this is less than 11.96 equals, we don't know what that is. So let's do our sketch. We were told that it's normally distributed, so it looks like this. We have to do a little bit of math to figure out what our mean is and what our standard deviation is.
Standard deviation is 0.16. Isn't that number 4?
Mu of x bar, flip back. What is mu of x bar equal to? What's the formula for that?
Oh, that's
Just you.
Mu of x bar is equal to mu. Do we have a population average given in the question someplace? Does it say an average of all bottles?
I think it's right now.
Since there's 12 fluid ounces in each bottle.
So on average, there are 12 fluid ounces in each bottle. This is my average for all of them. So this is mu. So sigma of x bar, again, flip back. What's our standard deviation? There's a formula for this.
Sigma over square root of n.
Sigma over the square root of n. Yes.
Okay.
Since it's an x bar problem, we have a different standard deviation.
Okay.
So this is the formula that we use to come up with that. Do we have a population standard deviation? Is there a standard deviation given in the question someplace?
0.16 fluid ounces.
0.16 divided by the square root. Do we have a sample size given someplace in the problem?
11.
So you guys with your fancy calculators. 0.16 divided by the square root of 50. I don't know what's right, you just said it with confidence. So Alright, what's the value that goes on the middle of this? 12. Should I go right or should I go left?
Left.
Should go left, because this is less than half, so 12 minus 0.0226. Does that reach our thing? You need to go one more. Just keep on adding and subtracting that standard deviation till we get the value that we want.
11.96.
So 11.96 is in between here, but closer to this. Where do I shade? Above it or below?
Below.
Is my answer going to be huge or small?
Small.
It's going to be very small. So, I think I still have it. The average of this one was 12. The standard deviation was 0.0226. And right-tailed or left-tailed?
Left.
And I want less than 11.96. 0.08, 0.03. How do you finish it?
Saving.
Save.
Did you put 387?
Yeah.
Or 3837, so it would be 384.
Okay. 0.038. I forgot my 3. In the grand scale, it is the average of the difference there. Alright, statement. What did you find? Back to the question. What did you find?
Found that on average.
What is the probability of randomly selecting a sample that will have an average of this? So, I'm literally going to say the probability of randomly selecting 50 bottles
With an average of.
probability of randomly selecting 50 bottles that have an average of 11.96 fluid ounces or less is 0.038.
This we have to.
Can I say it's normally distributed? Nope. What's the information that, right, why can't we say that it's normally distributed? It says nothing up here about it being normally distributed. Your assumption only comes from the problem, not what you've done or not what you've calculated.
So assuming that there's 12 fluid ounces in each bottle.
And?
And the standard deviation.
Yes. I will put
multiple choice.
multiple choice. And then that's why we need to make a sketch. That's why we need to know the map. Right, I will give you the map on the exam. It'll be up there underneath your name, underneath the instructions. The formulas will be there. I will have this and these two. The only thing that you have to memorize is n times p and n times 1 minus p. That's the only part, that's the only formula there that you have to memorize. I'm assuming you guys can do that. It's 2 letters. Better or worse?
It's better.
I think that second round, that second time round is better.
Yeah. That's
Yeah,
why we
that's
should
the
probably
last
just be
box,
doing
yeah.
this.
You wanna do another?
Is you said the next exam is Tuesday?
It's a week from today. Alright. You guys wanna try number 5?
Yes.
Alright, try number 5.
Thank you. Yes.
Alright, I will leave this up here for you guys to attempt number 5. Use your chums, use your notes, use whatever you have to. Just leaving this up here for number 5.
Like over to right. Well, that's not.
So pass.
There's a Hawaii one.
Right, that's how this one.
So there's an easy one.
Yeah.
Thanks.
Can I erase this half?
Yeah, yes.
No, I don't want to.
What did you think?
I want to keep this one because this is a p-hat question. So then you guys can refer back to this on how to do this one.
So, how many friends do you have?
This isn't about me. I have one.
Okay, well, how many does this person?
This is you guys and your guys' You guys are all like hip.
Okay, but how do you?
Can you not word one like this on the exam?
I have put all these on the exam, and then
Don't
yeah,
do this one.
you're right because it's the wording of the your friends. That's the problem with it.
What do you mean the closest?
What's that? Don't think of it as your friends. Just think of it as 250 people.
Oh. So that's less than.
There. Is that much more better?
Yeah.
Would you, before you keep going,
Yeah.
would you take points off for someone in the label if they put, let me happy the proportion of 250 randomly selected people?
That's fine.
And they're in 9 countries, can't find, no?
Yeah. No, that's fine. As long as now you're just like nitpicking all the details. So, and for me, I just want to. No, I completely understand. But for me, whenever I make my key, I'm talking like general.
Wait.
Do we say if the sampling distribution of the sample proportion in the condition?
There's an issue with time with this, as you guys can see. Even in my 75 years of doing this, that still took me 5 minutes to write all out. So we have to get very, very quick at knowing label, conditions, math, statement. That's the issue with this exam, right? I've done this exam where I plan on it taking you 40, 45 minutes to do just the open-ended. That still gives you roughly half an hour to do the multiple choice. So if I have 15 multiple choice questions, that's 2 minutes a question. Time's a problem. You guys can see how time is an issue with this. This is why I will be here 5 minutes early. You guys have 5 minutes afterwards, right? So I try to give you as much time as I possibly can for this. However, how do we get good at this? Repetition. So
How did you get 0.2?
it's like 0.18. I just rounded it because I knew the math.
But I'm getting 0.00036. But I heard. How did you get that? How am I gonna get a different answer if I say 2 minutes after this is
Okay, so there's a couple things before you guys like completely start ignoring me. Underneath that same in Blackboard, right there at the very bottom, the sampling distribution, there are 2 completely completed examples. One of them is the one that we just did. This is why I didn't really want to do it. To where I go through label conditions. I did 5% instead of 10. They should have been a 10%. But this is everything that we just got done doing for all of this. And then there's another one for proportions. This is a completely different proportion question, so it is still there. All this stuff is still there. There's more things, right? So I've done 2 of these. I've done 2 of the X-bar questions that you guys should have in your notes. There are 2 of them in Blackboard completed all the way through. So there are templates for you. The other thing, in order for you guys to get good at this, there is 2 questions. One of them is going to be X-bar, and then the other one is going to be P-hat. Just repeat exactly what we have been doing in class. Does this make sense? I don't want you guys to get, in fact here, but let me address something. I haven't mentioned this in class because I don't think anybody cares. But when you read the statement for this guy right here, you see where it says this?
By the central limit. I see what I mean.
Yeah. I don't care that you guys know what this is. You guys don't have to put this in your statement. We have been doing the central limit theorem with all of our conditions every single time. I don't think students care. It's not like a major part of this class to be like, yeah, I am doing the central limit theorem. Look at me go. No, I don't care. Nobody cares. You just have to be able to apply it. So I put it in here just because I just put it in there. You do not have to include it in your statement. Your statements can be exactly like what we have been doing up here. Okay? There is homework, right? Underneath the in-class assignments, 2 questions, right?
The 2 questions you just showed us?
Yeah, one of them is about like the average weight of people who get in an elevator. I'm fat, I need to know this information. And then the other one is about proportion. A proportion of people who go to Florida over spring break or something like that. So there are 2 questions. Those things are due on Thursday.
They're just like these questions?
Yes, they are exactly like these 2 questions. Right, one on each side.
Where are they again?
In-class assignments. Hold on. If I click on in-class assignments, it's the only thing that you see. You don't have to type it out. You don't have to print it out. You can do it on your own paper. I don't care. It just you guys have to practice this. This is a major part of the exam. You guys have to know how to do these steps. Yeah.
Is that what you would reflect in?
Where are other homework?
They're online, web assignments are.
They're graded, right? The one we did already?
No, I haven't graded anything. I will grade that paper that you guys turned in last class. I'll have that for you next class,
Okay.
and then I'm gonna do something else. Mackenzie.
I was gonna ask you the same question as how you got the 21,587.
I know.
That's what
It's a stupid thing that I know. It's one standard deviation below the mean and it's less than that. So you can go to SALT and do, what is the mean? 0.90. And then this is 0.02. And you want less than? Or you want greater than? You want greater than. And this is 0.1587.
So on the exam, how do we?
And we'll talk about that, but I'll give you multiple choice.
Oh, yeah. Okay, never mind. Sorry.
Here.
Sir.